Dave Tomlin from Hitex in the UK. We are a subsidiary of Hitex in Germany, and we do many of the same things but we're a relatively small company with only 17 people rather than the 100 plus in Germany. We have a specialism in a couple of areas. We'll move on through this quite quickly. So we do a little bit of hardware design, designing PCBs to your specifications. Writing software, especially safety critical software for various applications. And we do quite a bit of training in the UK in various fields, including writing software, Cortex and PROFIBUS. We also sell quite a range of products, those helping you write software, such as the Kyle software, embedded boards and modules for fast tracking your design, getting you started, or just making life easier, getting things moving. And most interestingly, industrial automation products. We've been a partner of Softing for over 20 years now, providing parts to the UK and Ireland. Softing are a growing company. They have a huge range of products from OPC, helping you connect machines together, gateways, again, helping you connect various parts of your factory together, diagnostic and monitoring tools for when things don't go quite as you'd hoped. And now, as we move into this new area, we're starting to do industrial networking tools with the APL switch and various other things. So that was my very short introduction to Softing.
So let's start straight into it. So if you look at the status quo in process automation, that is a slide from the Ethernet APL, Ethernet to the field brochure. So what we have in the industry is not a little bit like my background is also a lot in the telecom industry, embedded industry, and that usually what happened is we started with 10 megabit, then we had 100 megabits, and then gigabit, and the newer technologies replaced the older technologies. Here in the process automation, I think it's quite different. So if you look at this picture here, we have, if you leave pneumatic behind us, and if you look at analog signals we have based on 4 to 20 milliamps, how it all started. Then what came on top was hard. That was the first time going a little bit more into the digital space. So with 1 to 2 kilobit per second to have more than just one process value, and going to field bus, which is a real digital bus. Might be PROFIBUS PA, or a lot in the oil factor is a lot of field bus in there. The interesting part is that it is not that now everything is field bus. So the status today is still that 70%, 80% is still based on 4 to 20 milliamps analog signals, some of them using hard, but only a small part of it is using field bus. So one thing is, why was that? Because field bus is an interesting technology. You could transfer much more data. You have probably a factor of 20, 30 in terms of speed compared to hard. And I think one of the main reasons is, and we are not at Ethernet yet, but that's where we want to go. And one of the main reasons is it's still quite complicated, because what you need at the end of the day, there's still a break in terms of the network. You still have to transfer from PROFINET over to PROFIBUS, from Ethernet to PROFIBUS, a different kind of network and physical layer. So one thing is, it was still very complex. So people in the field were used to analog signals, a little bit of hard, had also learned new tools, and it was much more complex than expected. So the adoption of PROFIBUS PA and foundation field bus is probably even more complex. One of the reasons why that didn't happen directly is there was a big hurdle in terms of complexity. That was one thing. So if you look a little bit, then where are we today if you look at digital? Okay, on top you see you have engineering tools, you have a plant asset management. Just to explain the topology quickly, you have an industrial switch, a Cisco Juniper switch, just an industrial switch connecting to PROFINET. So that's all Ethernet based up to the gateway. From the gateway, we have the PROFIBUS PA in terms of process automation, which goes to the field devices. So as you can see here, there's the break in the gateway. And for example, we have, for more than 10, 15 years now, we have products that connect the PROFINET to PROFIBUS PA field devices. Here in our nomenclature, it's called PN Gate PA. Sounds pretty complicated. It isn't really, because PN stands for the north side, so PN stands for PROFINET, Gate stands for gateway. In this case, it's not a gateway, it's even a proxy, which has a higher functionality than a gateway. And PA stands for PROFIBUS PA. So when you see our nomenclature in Softing, the first two characters is the north side, then it's the function gate, and PA is the south side. So that's one part of it. The other thing is, if you look into extrinsically safe, you still need on PROFIBUS PA, you need power condition and the field barrier to get this, to make this intrinsically safe down here. So quite a bit of complexity as well as additional hardware for that. And as I said before, you still have this kind of break that makes it much more complex. Also for configuration, for setting it up, for parameterization. So if you go to the requirements of the process industry, we have a very conservative industry, but that's understandable because these plants have to run for 30, 40 years. And usually you don't change a running team if it's not really necessary and if you don't get additional benefits. So the requirements that we got out of the industry were high-speed data rates. So compared to PROFIBUS PA, which is a speed of 31 kilobits per second, that is probably not what you want to have in the future. You already can transfer a lot of data, but it still takes some time to transfer it up, but also for parameterization, that still takes some time. So high-speed data rates is important. Interesting for me is in the telecom world, I remember when I was in the beginning of the 90s, my first modem had 32 kilobaud per second, and that's 30 years ago. So it's the same speed here, but under other requirements in terms of intrinsically safe. So high speed is one they would like to have. Future-proof network infrastructure. So as mentioned before, I mean, the run time for a plant might be between 20 and 40 years, so it has to be future-proof. Why is that also a big topic? That's because some people in the PROFIBUS PA community say, okay, how long is PROFIBUS PA still alive? Because if everybody moves to Ethernet APL, then also the big manufacturers for the field devices will move into this direction. So the requirement was pretty clear: future-proof network infrastructure for the next 20, 30 years. Long ranges, especially in bigger plants, we have quite a distance between some of the devices. So long ranges is a must. That's existing already in the 4 to 20 milliamps, as well as the PROFIBUS space. Extensive diagnostic capabilities. So the other thing is you want to have diagnostics in real time, and you want to get it from all the sensors you have in the field to figure out, is there maintenance important, for example. And that, given the fact that we are going to have less and less really skilled people in the field who do this directly at the field devices or at the switches down in the plant, that might be even a more important issue to allow us remotely to access that, to get the data, diagnostics, and to make sure that we fix a problem before it even occurs. Last but not least, seamless integration of field devices. So really Ethernet down to the field would be ideal. That gets rid of a lot of complexity we have today. So what's the path to Ethernet into the field now? So let's start quickly with Ethernet APL. What is it? Just quickly. It's advanced physical layer. The reason I made the physical bold is because it's just the physical layer. So if you look at Ethernet APL, it's nothing else than a cable. It's nothing else than a Bluetooth connection or a wireless connection or a LAN cable. So it's really the physical layer. Two-wire cable, mostly twisted pair, data transmission and power supply. Cable length up to 1 kilometer. It's intrinsically safe. That's designed what it's made for. And it allows for 10 megabits per second into the field devices. We talk about the speed in comparison to the other technologies in one of the next slides. And integrate seamlessly, as I mentioned before, to make sure that we can also use tools that we are used from Ethernet. So if you look at that, I mean, it's really, as mentioned, if you look at that, twisted pair, 10 megabits per second, power over the line, and X-safe. So that's probably the picture it's interesting to remember when you think about Ethernet APL. And what's on top, like PROFINET is what we support, hard IP and some others, that goes on top. And for these kind of protocols, it doesn't matter which kind of Ethernet technology you use on the physical layer. Technical attributes, I don't want to go into all the details because that probably would kill it. There are just a few things I want to put the focus on. One is the standard is based on an IEEE 802.3 CG specification. That's mainly similar to what you have already at home if you have a 10 megabit per second connection. It's also added is type A for intrinsic safety, following the IEC specification. And it has the 10 megabits per second full duplex versus the 31 kilobits PROFIBUS PA, so a completely different speed for that. So these are the three things that's probably interesting. One we're already familiar with Ethernet, we can use the same tools, intrinsically safe and 10 megabits per second. So if you look at the speed comparison, and that is, as I mentioned, we are only on a physical level. So that's only how fast the bits go from left to right. So hard, I mentioned that before, 1 to 2 kilobit per second. Then we have the PROFIBUS PA with 31 kilobit, and we have the 10,000 kilobit here on Ethernet APL. That's a theoretical value. If you really look at, let's say you run a PROFINET protocol on top, then you have some frames, you have to some protocol overhead. So the assumption is roughly that between hard and Ethernet APL, we probably will get a factor of 50. That means just roughly to give you an indication for parameterization, but also for reading data. So with a factor of 50, that means what you need 5 minutes for so far on hard, this will be done in a few seconds, which saves you a lot of time. Network structure, how does it look like? Industrial Ethernet, typical 100 megabits per second on copper, 4 wires, devices on switches, then need auxiliary pair from outside. Ethernet APL has the 10 megabits, 2 wires, power over the communication line, and can be intrinsically safe. And the topology that is used today is, this is a classical industrial switch. Then that's a connection from, in this case, from an industrial Ethernet into the switch. Power comes externally. That gets transferred to the different spurs. Spurs is the name for the south side of it, to the field devices. Trunk is usually the name more to the north side. So that's the topology that is used at the moment. There are, I don't want to go into detail for that. There are 1, 2 more probably for the future, which are a little bit different based on the same technology. But that's what everybody's supporting today in the industry. So if you look at a use case, let's take brownfield, for example. Again, same picture we had before, switch, you have the PLCs, the DSCs here, then it goes into a gateway to the different Profibus structures. So instead of the PN gateway before, we have an APL switched field. That's the name of our switch technology, 16 spurs down there, and here two trunks up for redundancy issues. And what we actually did is we integrated our existing PN-Gate PA technology into the switch. That allows the switch not only to handle Ethernet APL, but also to handle Profibus PA. The beauty there is you can really have a mixed topology. There are probably 2 scenarios. If you have an existing PA plant and you want to expand that with Ethernet APL, you can use the same device you used before, and you can add Ethernet APL devices to that. And the second scenario, it might be you want to set up greenfield, also ideally greenfield, an Ethernet APL based plant, but you can't find all the relevant sensors or actors on Ethernet APL, you still can for certain. That's a bit the idea behind these 2 scenarios. In addition, what we do as Softening, because we are not only an infrastructure vendor, we have some sort of what we call a co-module APL. And the idea behind this one, that's only on project basis, that we help field device manufacturers, which have more niche or exotic parts, to integrate their existing products, probably based on Profibus PA, very quickly on Ethernet APL. The way how we do that is actually we have a so-called co-module APL. It's a hardware module with some software on top. So at the end of the day, that gets integrated by the manufacturer, by the field device manufacturer into the field device. Here, that's a nice picture that we also had on the last ACHEMA in June here in Germany. When you open the lid, you can see that's exactly our hardware module in there. So hardware module and software module. So this does all the integration of all the functionality with the interface to the Ethernet APL. The other things like what's already existing on hard or other technologies you can actually reuse, and this one helps you to interface very quickly to new technologies. So it's not only the switch technology that we do, but also for field device manufacturers on a project base, we help them to adopt very quickly to new technologies like Ethernet APL. So if you look at the field quickly that we have, field switch with industrial Ethernet, external redundant power supply, you get the presentation data, and I don't want to spend too much time on this one. Here's different levels of X. You have the possibility of 16 spur ports. Spurs, as I mentioned, are the ones here to the south. With PROFIBUS PA device support, so you can mix it up. You can have 5 PROFIBUS PA devices here and 5 Ethernet APL devices, so completely free to use that. PROFINET enabled MRP for redundancy, conformance class B, and detailed diagnostics, and that goes probably too much into detail. FDI package, it helps a lot if you want to have access to an asset management system. And integrated web server and local display, I'm going to show you in the next few slides. If you start with the web page first, I mean, you can see that's a web server in there. That's just a picture of the switch itself here. On top, we have the trunk ports. This one is trunk 1 and trunk 3, which are connected here. You can see there. You see communication there. The signal noise ratio is 49.27 dB on there. That's to the north side and to the south side. So you can see on spur 2, there's a 10 megabit per second that indicates the Ethernet APL connection with an SNR and power. So power usually on power class A on Ethernet APL is a little bit more than half a watt, 0.553 watts that you can see here. And on spur 6, you can see that's a PROFIBUS PA connection. So it's mixed between Ethernet APL and PROFIBUS PA. If you look at the local display, that's here actually on top. If you look at the switch itself, you can see these are not only the LEDs, but also information regarding the trunk spurs. You can read the IP address if you want to. That's only read access. So you can't write anything in there. That's also not the idea. It's really the idea that you get directly on the device, you get the relevant information directly at the switch. That's the idea of this display here. Greenfield would be then the next level. So if you really say that's something, I don't need PROFIBUS PA any longer. So at the end of the day, what we have, the different kind of devices here is an APL. And that is then the first time that we really have seamless Ethernet down to the field devices. From plant asset management, engineering tools, whatever you need, over the switch directly down here. So we have a second version of the switch, which is a little bit cheaper because it doesn't have the PA proxy, because it doesn't need the PI devices to be connected for greenfield. The additional thing we did is we added the same number of spurs, but we added on the last 4 spurs, we added an additional power class. This power class B allows not only half a watt, it allows more than double of that. The reason is that we got requests from field device manufacturers that said, okay, I want to put more intelligence into my field device. So at the end of the day, I need more power into this one. And I don't want to use external power. I want to get this power over the line. That's the reason why class B with more than 1 watt is included in this version of the switch. So very important is also the ecosystem. So the validation with the systems. One is distributed control systems. For example, okay, one of the leading ones is Simatic, the PCS7 from Siemens, Delta V Emerson, and the 800 main series we see at the moment. So validate with these DSCs. And also because especially bigger appliances want to have also asset management system. These are the companies we're working very closely on to introduce these asset management systems as well. Because at the end of the day, what's very important is that it's not only supported by the switch vendors, but it's also supported by the complete ecosystem. That means if you look at the different players in this kind of market, end users and operators, BASF, for example, they're heavily involved in that, but all the big German chemical companies are involved, having dry runs or even having this already in production. Then we have the control system suppliers, as I just mentioned, DC suppliers supporting that, EPC system integrators who do all the integration work actually for the end users. They're heavily involved in that. The field device manufacturers, as I mentioned before, like companies like Anderson Hauser, Vega, and so on, and the APL infrastructure manufacturers, which also contains all the switches in there. So from an end customer view, if you look at Moore, which is the chemical industry here in Germany, they really make it really, really clear. And together with the ZVEE, this is more the guys who actually do all the manufacturing production. They really want to push that forward. They say that's probably the last chance to put the digital world into the process automation. They're heavily pushing on that. They're having prototype plants working on that. They have compliance tests that it all works seamless with each other, and that works very, very good. So the really also their thing is here in Germany is that they really say technology is ready and tested. There are more and more devices, field devices, but also switches coming up, and they really has not only started to adopt it, they really have the technology right now. So the idea really, we are ready to go from a switch perspective. It's integration into DCS. That's important for us. The same for the AMS, things like that. There's no additional gateway, there's no additional hardware needed if you want to access Ethernet APL or even PROFIBUS. Easy commissioning and maintenance, and the other thing is also very extensive diagnostic possibilities via this kind of a switch. And last but not least, that's a picture I want to end up with in the last minute is, so we have, as I mentioned before, we help the field device manufacturers. We have products like the switch to transfer this data over to, in this case, to PROFINET, but we also have additional products that allow the plant asset management seamlessly down to the field devices. So our setup is not only okay to have a piece of hardware or support, but it's really the idea at the end of the day, the value to the customer is that via the plant asset management, via HMI, he gets all this information up there. That's our job to make this possible with our hardware as well as with our software.